Okay, so this is a very important section about methods. Methods are also called procedures, at least in this text. And now you've already used a method, and I think you've even written one, because this is actually chapter 3 of this book, but we've gone through chapter 4 already. So if you recall, we had this method before. We created the clear list method, and then we used it many times to clear the items on the list box. So, and remember how we wrote this. We said private sub clear list. So that was the name, clear list. We have these brackets here. We had a comment next. And then actually we only had one line, which said list friends, which was the name of the list box, and items.clear. So we actually used another method to do our method. So since we've already done chapter 4, you've already done this, but let's explore the details of it now. So they say a method is a self-contained block of code that does something. So we just created a block of code that did something, that cleared the list. Methods, also called procedures, are essential for two reasons. They break up a program and make it more understandable. So if you have that method, then you know what it's doing. You don't have to read through all the code to try and figure out what it's doing. It's sort of clear just when you use that method. Instead of, if you had to write all that code there, you wouldn't know where it started and where it ended if it was mixed in with other code. So it definitely makes it more understandable, makes the code or the program more understandable. And second of all, they promote code reuse. And you saw that we reused that clear list method many times, and that's a good thing. It's good to have code that you can reuse over and over again. First of all, it means you don't have to rewrite it over and over again, and also again it makes it easier to understand. Now he relates this to the discussion on algorithms before. He says, as you know, when you write code, you start with a high-level algorithm, but then, you know, we said that each of the steps in the algorithm might need to have finer steps within it. So he says, and you keep refining the detail of that algorithm until you have the software code that expresses all of the algorithms up to and including the high-level one. He said a method describes a line in one of those algorithms. For example, you might have a method that opens a file. You might have a method that displays text on a screen. So that might be just one final sort of fine line in the overall program and the overall algorithm, or print a document, and so on. Now one thing is, it's not so easy to know when to write a method. It's kind of like an art. And it comes from experience, not really, and so, you know, might have some good insight into it, but it comes by doing a lot of practice. I mean, writing a lot of different programs, and then you start to say, oh, I could make a method out of this, and you do that. So he says, knowing how to break up a program into methods is something that comes with experience. So he means it's not so easy to figure it out. And then he says, to add to the frustration, it's far easier to understand why you need to use methods when you're working on far more complex programs than the ones you've seen so far. So he's saying that when you have a big program that you're trying to do, then it's easier to see that you need methods. But we're not doing that, right? We have just small programs, so it's hard to see why we need a method here. So it looks kind of artificial that we're creating methods. So, but that's the situation we're stuck with, because we're working with not so difficult programs right now. So he says, why do we need methods? So when we're doing programming, we need to pass information to a method for it to produce the expected results. This might be a single integer value, so we might give it as input to the method. Now, our clear list method didn't take any input, but sometimes methods will take input, and they might take an input like a single integer. It might just take a number, or it might take a string value, a set of string values, or a combination of both, and then it might do something with this information. So not all methods have to have inputs in order to work. Like we saw, clear list didn't need anything. But when it does take some kind of input, these are known as input values. However, some methods don't take input values, so having input values is not a requirement of a method. Anyway, but the method uses these input values and a combination of environmental information. Now, they don't mean the weather there. They mean like in terms of what's going on in your program. Take some other information that you're doing in your program. For instance, facts about the current state of the program that the method knows about, and it does something useful. So it takes the environmental information and the inputs, and then it does something. They say, we call it passing data. They say, when you give information to a method, you're said to pass it data. You're passing the method some data. You're giving it some data. You can also refer to that data as parameters. So the stuff that you're putting in as parameters. Now, I've been using the word arguments, and in some languages they make distinctions between parameters and arguments, but it looks like he's using parameters here. Finally, when you want to use a method, the word you use is you say you call the method. So you pass it data and you call the method. And the data that you pass it, you can refer to that data as the parameters. He says, to summarize, you call a method passing data in through parameters. Now he says the reason for using methods is to promote the idea of code reuse. The principle behind using a method makes sense if you consider the program from a fairly high level. So what they mean by fairly high level is like not the little details of the program, but sort of what it's trying to do. If you have an understanding of all the algorithms involved in a program, you can find commonality. So you might be wanting to clear lists many times. If you need to do the same thing more than once, you should wrap it up into a method that you can reuse. So what do they mean by wrap it up? Well, in this clear list example, actually the only thing we're really doing is this, and we needed to do it many times. Now, as I said, it's sort of artificial to create a method for this because it's really just one line. But like he said, we're trying to learn how to use methods, so even in this simple case where it wouldn't even really be needed, we're going to make a method out of it. But anyway, we are calling this, we're actually calling this many times. So since we're doing something many times, or let's say not we're calling it, let's say we're doing this code many times, since we're doing it many times, we should wrap it up into a method, which is what we did. When we wrap it up, it means put this on top of it, and this on the bottom of it, so that it's a method. Okay, actually it's already a method, like I said, but maybe in other cases we'd had many lines of code that we were repeating often, so we'd wrap all that up in this and this. So once again, if you need to do the same thing more than once, you should wrap it up into a method that you can reuse. So he tries to give an example here. He says, imagine that you have a program that has many algorithms in it, like a lot of code, and you have and some of those algorithms need to calculate the area of a circle, and maybe the area of a circle depending on its radius. So you're given a radius at different places in the program, and then you have to calculate the area and then use that somewhere. So he says, So suppose that happens multiple times in your program, in your different algorithms that comprise your program. Because some of those algorithms need to know how to calculate the area of a circle, it's a good candidate for a method. You write code that knows how to find the area of a circle given its radius. So the input will be the radius, and then you'll calculate the area. And then you wrap it up, they use the word encapsulate it, which is a programming term. So you encapsulate it into a method. So you make a method that can do this. With input, it has the radius, and the output is the area. And then once you have that, you can reuse this when you're coding all the other algorithms that need this, need to be able to do this calculation, need to be able to calculate the area of a circle. This means you don't have to keep writing code that does the same thing. You do it once and reuse it as often as needed. So he says maybe one time in the program you need to calculate the area when the radius is 100, another time when it's 200, and so on. By building a method in such a way that it takes the radius as a parameter, you can use the method from wherever you want, or in other words, when you need it to calculate 100, or when you need it to calculate 200, or whatever. So that's a pretty simple method to build, isn't it? Think of what you'd have to do. So you're given the radius, and then you want to calculate the area. Now, I hope that you remember that the area of a circle is dependent on the radius, and that the area is the radius squared times pi. So it's a very simple calculation, but suppose you wanted to make, again, these are kind of artificial to make a method for this because it's so simple. But anyway, suppose you wanted to make a method for this. Okay, so what would you do? Well, we'll talk about it in a minute. Okay, so note, with Visual Basic 2010, you can define a method using the sub keyword or the function keyword. Sub, short for subroutine, is used when the method doesn't return a value. Function is used when the method returns a value. Okay, so let's look at some methods we've already seen. The good news is that you've been using methods already. Consider the following bolded code that you wrote at the beginning of this chapter. So this is what? A button click event handler, and we have an integer defined. We set that integer to 27. We increment it by 1, and then we display it. Okay, that code is a method. It's a self-contained block of code now that does something. Now it doesn't have any, it's not a function, it doesn't take any inputs, right? So as we said, some methods take inputs and some don't. Or maybe this actually does take some inputs, but kind of obscure. This might be considered an input, and this might be considered an input. So maybe I shouldn't say that. Okay, sorry. It's not. I'm not saying whether it does take inputs, but that's not what I was talking about. I was saying it doesn't return a value, right? It just okay. Now you might be confused. I was very confused with this when I studied this at first. When they said it doesn't return a value, but there's a message box here, and it shows something. It shows a result, right? So I was so confused I couldn't figure out why they said it doesn't return a value. But they're talking about like when you have the square root function. They're talking about when you have the square root function, then you put something in 9 and you get something out, right? So that's what they mean by a function, something that returns a value. When you show something like a message box or something, they don't consider that. That's not considered to be returning something or returning a value. So don't be overly confused by that. Or I should say, don't be confused about that. Okay, so he says, this method doesn't return a value. So in that case, we don't call it a function, we call it a subroutine. So it starts with the sub keyword and ends with the end sub statement. Anything between these two statements is the code assigned to the method. Let's take a look at how the method is defined. So part of this was automatically created by Visual Basic, right? So this part was automatically created by Visual Basic because we're just as soon as we click on the button to get to the code, Visual Basic puts this here, right? We didn't put that there. So let's look at it anyway. First we have the word private. So the meaning of this keyword, he says, is discussed in later chapters. For now, think of it as ensuring that this method cannot be called by any code outside of this class, or basically outside of this form. Okay, so it's kind of restricted in its use, and we'll learn more about what kind of restrictions there are, but you can think of it that way. So it's private. Secondly, you have the word sub to tell Visual Basic 2010 that you want to define a subroutine. So we have private and we have sub. Third, you have this, and this is the name of the subroutine. So this is what it's called. And fourth, you have this by value or by val sender as system object, by val e as system event args. Now, first of all, this as, we recognize that. So this probably is some kind of like a data type or something like that. So that's probably saying what this is. It's probably some kind of, it's probably a system type system.object data type, whatever that means. And this is probably a system.event args data type, or whatever that means. But also, this means that we have this parameter and this parameter. Okay, so well, basically what this is saying is we have these two parameters here. Notice there's a comma here, right? So comma means that there's this is kind of a description of one of the parameters, and this is a description of the other parameter. Right? Commas always separate the parameters, so this means there are two parameters. So this is the parameter, and this is the parameter, and then these are kind of descriptions of that parameter, of the particular parameters. Okay? So that's the way to think about it. And then we have this part here at the end of this line, and it says handles btn add.click. Now btn add is the name of our button. That's the name of it. And .click is an event. So it says this tells Visual Basic 2010 that this method should be called whenever the click event on the control btn add is fired, they say. Is fired means whenever such a click event occurs. In other words, whenever the user clicks on that button, this is this should handle that event. And they say that when that event is fired, and so this code that starts here and ends, where is it? Here, should be run. Okay, let's stop here, and then we'll continue, and you're going to have some homework to do here, some forms to generate, where you're going to write some methods for yourself.